बोल सकते हैं।
स्टार्ट हो गया। Can say something.
Yes, sir. Introduction.
Hi friends, welcome you all to this live session of this course. Please ask any questions if you have. I'm very happy that many of you have participated in the discussion forum and asked many queries also. Please ask any more query if you have. Then, okay. So now we will discuss some of the queries which we have received from some of our friends. And it was, how can we check the strength of crude oil which is formed by pyrolysis process from polyethylene or polypropylene? So this is a nice question, and thank you for this query. So you see, when we use polyethylene and polypropylene and pyrolyze it, then we get liquid, gas, and some amount of char. Then this liquid which is formed, that will be having hydrocarbons, oxygen, nitrogen, and sulfur will be very less, will be negligible. And in this case, the strength of crude oil means we can analyze the properties of this liquid which we are getting and compare with the petroleum crude as well as different petroleum products like say petrol, diesel, etc. And we have done some experiment on this, and I will show you that data which we have seen that up to 150 degree, that is 30% mass we got. That is, which I mean, the liquid which is formed, if it is distilled through ASTM distillation, then with the increase of temperature, we will be able to collect the condensed vapor, and up to 150 degree centigrade, we have seen that in our case with polypropylene, that around 30% liquid we got at 150 degree centigrade, and 150 to 200 degree centigrade we got around 20% of liquid, and then 200 to 360 degree centigrade we got 50% of liquid. So this is a typical range which we can get from the liquid. Now if we see, say temperature versus volume, then we got one. So this is our diesel, this is our say petrol, and this was our pyrolysis oil. So this was a 200, so 370, like this. So 63 to 360, within this range we got the liquid products. So these are the properties of the liquid which we can get from the liquid which is formed from the pyrolysis of propylene. Other properties we can measure such as viscosity, density, cloud point, pour point, we can measure and compare, and these values we have provided in we have given this in the pyrolysis of waste plastics. This chapter you will see we have shown in table how these properties are comparable with the petrodiesel and gasoline. Hi, hi friends. Am I audible? Please respond. Please write your queries. I see one response from Gaurav Oswal. Yeah. So, good morning to you also. Okay. Now, we'll discuss another query. It is asked how we recover the gas from syngas. How we recover the gas from syngas. Please also discuss about gas analyzers. Hi Abhishek, good morning, and I welcome you. How do you enjoy the course? Are you enjoying this? चला जाएगा कैसे जाएगा ये? हाँ? कुछ करना है? Yeah. Yeah. Thank you, Abhishek. Your question is, in case of plastic, as you know that they cannot be decomposable, neither they can be denial for daily use. Can we have better alternative for reducing plastic related waste? Okay, very nice question. As you know, that they cannot be decomposable, neither they can be denied for daily use. Yeah. Can we have better alternative for reducing plastic related waste? Yes, that is a very nice question, and this is the one of the important issue actually. All of us are thinking what are the alternate. Um, there are a number of thoughts, you know. One thought is that how to reuse these plastics, because as you have told that because of its advantages, even the government ban is also not working. Okay, so strict regulation that also failing. People are doing it at their own. So we have to create awareness program one way, so that as well as we have to provide alternates. Okay, so people are trying for it. Research are going on to develop alternate materials, and nowadays the biodegradable plastics are being investigated and being developed. We are also working on, to some extent we are trying to get some polymer from the waste also. Similarly, this type of research is going on around the world. And biodegradable, the biodegradation of polymers is also another research. Some group is also working to degrade the plastics by the use of suitable microorganisms. That although it is in research scale, it may take time to get advantage in advanced stage. And these are the, I think, the alternatives we can think. One is the awareness creation, that people should use less amount of plastics, and then what plastics we are using, we should use it for recycling process and energy recovery and other production of other products also. Nowadays, you know, by the recycling of materials, plastics, we can get low graded plastics for other application also. So that way, and another is your alternate materials. The plastics will be replaced by some other materials. That is also research is going on. Some composite materials are being also used. So that way the efforts are going on. Yeah. Am I audible, Abhishek? Is it okay? Yeah, yeah. Okay, okay. Please ask some more questions. Okay. Um, Now, before getting some more questions, I'll clarify another query which we have received through the discussion from. This is how we recover the gas from syngas, and please also discuss about gas analyzers. So, syngas, as you know, it is produced from carbonaceous materials through gasification under controlled amount of oxygen, and it contains basically carbon monoxide and hydrogen and some other impurities. Okay. Abhishek, I am coming to your questions now after replying this the syngas query. So this syngas is having H2 and CO. Apart from this, it is also having some impurities like H2S. So basically, the CO2 uh, and H2S, these are two major impurities. So we have to purify the syngas from these impurities, and we have discussed in this gas cleanup sections, syngas utilization, part 1, the how the gas is cleaned, and then how the ratio of CO and H2, the CO and H2 ratio, how this can be, the CO and H2 ratio, how this can be monitored, which is used for different applications that we have discussed in the gasification PPT and the video. Now, gas analyzers is also used to analyze the composition of gas. Basically, GC gas chromatograph is used to identify different gas molecules qualitatively and quantitatively, and also able to separate the gas components. It has two modes. One is productive, another is analytical mode. But in this case, gas is separated and then it is sensed. Some of the properties of the gas of the gas are actually sensed. There are some sensors, a detector. So some properties like say thermal conductivity or electron generation during photoionization or say light absorption capacity. So these properties are varying from different gas components, and depending upon the concentration of these property changes. And if we have some detector to sense this variation, we can quantify the gas composition, and that is the role of the gas analyzer. Yeah. So now, Abhishek, your question is, in case of energy generation from waste, which are clean process so that they don't disturb environment and fulfill goals of sustainable development. In case of energy generation from waste, which are the clean process so that they don't disturb environment and fulfill goals of sustainable development. Yeah. You see, if we think about waste and want to convert it to usable energy, obviously it will create some environmental pollution. So we have to take action in two steps. One is your prevention. I have to go for the process modification or raw material selection, change in raw materials, etc. Pre-treatment can be done. Then, taking all those precautions also, there will be some production of uh, pollution, and that has to be treated. So which is going on, yeah, treatment, and then your water treatment has to be followed. Then we will get the cleaner options. All combustion technologies generate pollution, and we have to take suitable method for the cleaning of the emission as well as liquid effluent, or that is wastewater. So that we will get. Is it okay? How is it? Okay. Oh. Yeah. वो आएगा. ठीक है. What is this? This one is. Yeah. Any more question you have? Okay. Okay. Please ask questions, and until I am getting more questions, I will clarify some doubts or some queries which I have received through discussion forum. I have received one question through discussion forum that under densification table of densification 2 table 2 densification 2, there are some table under density table. Density after briquetting is less than before briquetting. Please explain. So this is the query. It is very interesting question. Actually, basically briquetting is done to densify the solid material, a solid biomass and waste. So it is how the density can be changed or can be basically reduced. It should be increased, because that is the main role of the briquetting process, to increase the density of the material, a density of the briquettes than the original material used for the production of briquette. But you have mentioned here that density is reducing due to the briquetting. But please see this table I have seen. This is not the density, it is the bulk density. So it is bulk density. So as you know, there are three types of density. There is a true density, apparent density, and bulk density. So in case of bulk density, the space is more. The pore volume as well as interparticle spaces are also considered as the whole volume of the material. But in real density, no pore volume and no interparticle the interparticle space is considered. So when we are making briquette, in particular example in this table, the raw materials are your rice husk and some gel. So some uh, peel gel like this, some rice husk. So rice husk is very small particle. Then when we are compressing it and we are getting briquette, so briquette is having more dimension. That is a 30 millimeter. So 30 millimeter size. Then when we will put the briquettes in a container, then it will be having more interparticle spaces. As a result, the whole volume of the pile will be much more, because the interparticle space is being considered here as a whole volume of the material. That is why we will be getting the less density. Okay, I have replied this through the discussion forum also. Please ask me if it is clarified or if you need more discussion, if you have any more doubt on it. Okay, so before receiving any more questions, let us discuss some queries which I have received through discussion from. I have received some questions, that is, what is seed volume? What is seed volume? So basically this is related to the BOD determination of BOD of wastewater, and in some cases we need to add additional microorganisms, and in that case very small amount of this microorganism culture is added to the dilution water, and that is the called seed volume. Yeah. Okay, any query? Okay, so we are clarifying another questions which I have received through the discussion from, and it is, can we measure TDS by refractometer? The refractometer will furnish us the percentage of the dissolved solids, and ergo by knowing the quantity of waste we can calculate the total dissolved solids in. So this is the question. So actually for the determination of any property, more than one method can be applied, but whatever may be the process, that has to be standard one or should be published in literature. So if, and it has to be repetitive, the process has to be repetitive. If we repeat this in several times, the results will be very reproducible and error limits will be less. Even in this case, it may also be, but we have to prove this, that the data are being repetitive. Yeah. Any query more? Okay, so now let us discuss another query which I have received through the discussion from. So that is, respected sir, I want to ask whether plastic waste generated from hospitals like saline bottles and saline tubes will be considered as hazardous waste or not. That is also very good question. Actually, the materials which has been mentioned here, these are under the biomedical waste. So these biomedical wastes are special type of waste. Around 85% of biomedical waste is non-hazardous, and around 15% is hazardous. So whether this will be hazardous or not, that will depend upon the source from where it has been generated. And basically these two items, these may have the possibility of infection, infectious materials may be present in it. And these materials without disinfection cannot be managed. And for biomedical waste management, some standard methods are available, and we have Biomedical Waste Management Rule 1998, but for hazardous waste management, we have certain other types of rules, that is Hazardous Waste Rule 2016. So that way we can apply different methods for the management of these wastes also. Now hope it is clear. Hi Pushparaj. Thank you for your query. Your query is, can you tell me how to calculate TOC? TOC is total organic carbon. So what happens in wastewater, both organic and inorganic, both carbons may be available. So if we apply heat, so then the carbon will be converted in presence of oxygen and heat. If it is available, then it will be combusted and carbon dioxide gas will be produced. And that carbon dioxide gas will be sensed or will be measured by some detector and sensors. And depending upon the concentration of CO2, we can, after calibration, we can say what is the concentration of the organic carbon present in the wastewater. And this oxidation, some catalytic methods can also be used, some catalyst may also be used, so that at lower temperature the organic carbons will be converted into CO2. And another way, if you want to get the inorganic carbon, so inorganic carbon can be converted to CO2 at low temperature heating or by adding some acidic solution. So by adding some acid also, the carbonate can be converted to CO2. So that way, carbon dioxide which is getting at low temperature, that will be for inorganic carbon, and at high temperature we'll be getting total carbon. So total carbon minus inorganic carbon will give us total organic carbon. So this is the method which is used for the determination of TOC. And we have also received one query on TOC determinations, and I want to once again clarify it. I have already clarified through the discussion from. Still, as I have got an opportunity to, so I am again clarifying it. The question was, why hydrocarbons is injected with air in the TOC measurement process? So which we have in our slide, that it was mentioned that air free from carbon dioxide and hydrocarbon. So here during oxidation we get the conversion of carbon to CO2, and then CO2 has to be carried by some carrier gas for its analysis, for its detections by using some detector, NDR, non-dispersive infrared detector. So the carrier gas along with combustion gas can be produced by the cleaning of air. So air, when we are compressing it, that will be containing some amount of hydrocarbons. So that hydrocarbon and carbon dioxide present in air has to be freed from it, and that is done by using some membrane methods, and then these materials are removed and free from hydrocarbons, and CO2 is used basically for the generation of CO2, and that is measured by the use of some detector or sensor. If I have given some in the discussion from, I have given the reference where from you get more information about it, and it is mentioned in the reference that the carrier gas should be free from CO2, CO, and H2O. The hydrocarbons less than 0.05 ppm, CO2 less than 1 ppm and water vapor less than 1 ppm and CO less than 1 ppm. So these are the requirement for the carrier gas which is used for this TOC analysis. Now hope it is clear. Okay. So now we have another question from Amit Kumar Chaurasia. Hi Amit, thank you for participating in this live session. So how does the composition of waste takes in part of the process of pyrolysis? Can you define what is waste? Yeah, nice questions. So waste, that the materials which is produced from the any process or some activities, human activities, and the material, the product is not the prime interest of the producer. So that is waste. And pyrolysis, we know that when we apply heat to some carbonaceous material, in absence of oxygen, it is uh, it is vaporized first, and then vapors can be condensed, which can go through the secondary reactions also, and condense and form liquid, and some part also converted to solid. So this is the pyrolysis. Now, as it is a thermal method, so water is not desired in it. So the materials, the waste which are having less moisture content, that can be used if it has good amount of carbon. So the composition having high carbon and high hydrogen, less oxygen and less moisture, that will be used for pyrolysis more suitably. Okay. Yeah. So your another question is how the pyrolysis of plastic waste differ from pyrolysis of biomass. So here the composition you see, the plastic waste are basically completely hydrocarbons, carbon and hydrogen. There is very less oxygen and other atoms like nitrogen, sulfur, etc. But in biomass, we will be having more oxygen. So oxygen, due to the presence of oxygen, the composition which you will get in the biomass, in the pyrolysis oil, will be different from that which we will get from the waste plastics. So waste plastics can give us very uh, very similar fuels like diesel and petrol, but biomass pyrolysis will not give us the petrol and diesel as such. They can give us biodiesel and biodiesel, in which oxygenated compounds are there, and those will be deoxygenated in the pyrolysis. From the pyro oil from the biomass will be containing oxygenated compounds, and we have to deoxygenate it, and then we'll get the biodiesel. So that way these two feedstocks are different and products are also different. Okay. Am I audible? Is it okay for you? Okay. So next we are going to another query we have received in this. Yeah, what is the difference between biomass and waste? And tell me how good to do some startup in the solid waste management sector in India. That is, I have received this question through the discussion forum, and it's very interesting and nice questions actually. The what is the difference between the biomass and waste? Waste, as I have defined, that it is the materials which is produced through some activities or processes, but not of prime interest of the producer. And the biomass is a material which is generated from the living organism. So the waste can also include biomass. Okay, and it has been seen that municipal solid waste contains good amount of waste biomass. Biomass which is not in use, that is of the prime producer. Producer is not interested with it for its application, like say agricultural residues, forest residues. So all those things, the agricultural residues, the producer is not much interested to use it because of say economics or some other way, other reasons. So that materials are waste biomass. So biomass, by the definition, it is coming from the plants as a living organisms after the death of the plant body, and it is waste because the producer is also not interested much with it for its application. So those, that way biomass and waste are very, all biomass can be waste also. And the processing steps, the waste also have good amount of carbon and hydrogen. Biomass also have good amount of hydrogen and carbon. So if we want to get energy from both the stream, both the raw materials, the processing steps will be similar. Now the next part is how to start up. So this is a very interesting, and this is the need of the society. So obviously, government has tremendous effort, and they are putting um, large amount of money to encourage the people to take initiatives for the management of solid waste, because we have to do it for our sustainability. But how to start up? Then we have to think a business model, and then only you may get success. Okay, another question we are coming, because we have no more questions I have not received through the this live session. So let us discuss another question which we have received through the discussion from. So without proper time and visibility to each slide, how can we understand the subject? Please explain a little bit slowly if possible. So already the lecture is a video of the lecture is already made. So we have nothing to do with it. But for information, you will get the PPT at the right side corner of the web page when you will get the video, and you will also get the word files at the bottom of the left side of your web page of the NPTEL of this course. So when you will get the PPT as well as the word file, you will go through it, the transcript, and I think it will be, your problem will be solved. Any more question? I think the important queries which I have received through the discussion from this year, is clarified. Now, I had received some more queries in the last year also, because this course is running for, this is the third year, so we have some queries from the previous year also. So I want to discuss some queries from those. Okay, one new question I have come. So welcome, Shuvi. So your question is, what are the difficulties with the commercial application of plastic pyrolysis? So what are the difficulties with the commercial application of plastic pyrolysis? A very good question. Pyrolysis, already some companies are there, those are doing this, and I have given in the Signer Plastics their case studies I have provided in this. But this process requires good amount of heat. So this is a heat intensive process. So if we cannot select a suitable catalyst or suitable process which will give some diversified product, then it may not be that economically attractive. So that is the challenge for it, and but still, some companies are offering the technology for the production of oil from the waste plastics through pyrolysis route. Okay, another question I have received: what are the protocols should follow for COD and VOD calculation? So BOD COD calculation already we have discussed in the slide PPT, and we can go through it. Or there are, above all, there are some standard methods are there of American Public Health Association. So they have methods, standard methods. You can go through it. And seeding in BOD already we have discussed that in seeding in BOD means when we want to measure the BOD, then at that time in some cases we need to add some additional microorganisms depending upon the nature of the compounds present in it. So in this case we need to add some microorganism, that is a seeding process, those are called seeds. Okay, so next is this is one question in the last year which I have received through discussion from, that is, sir, and dear all, which is most appropriate formula to calculate GCV and NCV for a particular biomass? So GCV is gross calorific value and NCV is net calorific value. So in our PPT and in our video, you will see there are number of empirical relationship has been given to determine the GCV uh, on the basis of proximate and ultimate analysis. So all those methods are empirical one. So if I want to fix the price of coal or say waste materials or any carbonaceous materials, so those value will not be that useful. But if we want to compare, say I have 2, 3 substances, I want to compare, I want to pick up the best one. So then we can use any formula of it to compare the GCV, and then actually we will put it, we will measure the exact GCV value by the experimental method using Bohm calorimeter. So that way we can use these different formula. Okay. Any more question? Next is your what is waste? How can you determine a certain substance in waste? Yeah, it is very good questions. So what is waste we have already discussed, that which is not of that prime interest of the producer, and how we can define the substrate in it, how we can determine the certain substance in waste. So there are a number of methods which we can use for uh, this analysis. If it is wastewater, so wastewater has some quality parameters, so we will measure those quality parameters like say BOD, like COD, or is it phenols, if we have metals, etc., or pesticides. There are some certain methods we can use it. So if it is a waste, so say if it is a lignocellulosic biomass, we can go it to determine how much lignin is present, how much volatiles is present, and how much cellulose, hemicellulose is present. So different methods I have discussed in the lecture notes as well as in the videos also. So you can go through it. Yeah. So now, and now I am not seeing any more question now. So I'm going to another question which I have received in the past year, in the last year. Very interesting question actually. Why the waste which has the high moisture content cannot be used in the thermal conversion and be used in biological conversion? So if the waste is having more moisture and if I want to use it through thermal route, so I have to remove the moisture first. So it will be taking large amount of heat. So the process will not be that economic. But if we use the material with high moisture through biological routes, so then it will be feasible, because in biological route we have to maintain 8% to 10% solid, remaining is water. So that way it will be more feasible and economic. So that is why, so high moisture content materials, if it is biodegradable in nature, can be preferred to process through the biological route. Okay. Okay, so we are moving to another query which we have received in the last year. That is, could you explain the purpose why we find out BOD and COD? Correct me if I am wrong. BOD is the amount of dissolved oxygen needed or demanded by aerobic biological organisms to break down organic material present in a given water sample at certain temperature over a specific time period. What we do after finding out BOD value? Is it like we will supply more oxygen according to that? If it is less, that is also a very good question. Actually, BOD and COD both indicates indirectly the presence of organic carbon in the water. So BOD indicates that organic carbon which is biologically degradable, and COD is the total biologically and chemically, not total, that is chemically degradable. So these organic compound which is present in water, those will be degraded and will consume oxygen which is dissolved in water. So dissolved oxygen will be consumed by the organic materials and will be converted to CO2 and H2O. As a result, the dissolved oxygen in water will be reduced and aquatic animals and plants will be in danger for their life. So that is why we should maintain the BOD and COD level within certain limit. If it goes beyond that, then there will be difficulty and aquatic animals and plants will face problem. That is why BOD COD is measured. Now another interesting question which I received. That is your, sir, how can we set the dilution factor for different type of wastewater? Because the dilution factor changes by changing the type of wastewater. That is also a very good question. Actually, there are some standard methods for the determination of BOD. As per the standard methods, it is said that the DO value after 5 days should be more than one or more than one, and during these 5 days at least DO 2 ppm of DO should be consumed, and 1 ppm of DO minimum should be available after 5 days or certain, or maybe 3 days at 27 degrees centigrade or 5 days at 20 degrees centigrade of incubation in the wastewater. The DO available should be 1 or more than that. And another condition is that during this time period 2 ppm of DO has to be consumed by the microorganism. So to satisfy dilution factor, what will be the dilution? For example, say we have 8 ppm of DO, saturation DO. So after 5 days, it has to be 6 ppm. One limit, other limit 1 ppm. So in this case, what we are getting, so 8 ppm we had, now we will be having 6 ppm and 300 ml by 400 ml. So then we will be getting 1.5 ml. So what we are having, in other case we will be getting say 8 ppm and 1 ppm into 300 ml by 400 ml. So that is equal to 5.25. So this is 5.25 ml to 1.5 ml. Within this, any value of this wastewater has to be used to dilute it, so that this can be achieved, the target that the 2 ppm of DO will be consumed and 1 ppm of DO will be available. So hope you are satisfied. I have no more questions, and already we are running with less time. So thank you very much for participating in the live session.
Bangladesh.